Let me give you a walkthrough on the topics which we'll be covering as part of this series. So I have opened this Excel where I have just listed down some of the topics, a high level. Okay, and what we'll be covering? Introduction and basics of Terraform. We'll be covering Terraform providers, the CLI workflows like Terraform Init, plan, apply, destroy, the basic commands. Then HCL basics like resource, variables, outputs, locals, how do we declare them? So these things we'll be seeing, and we'll be covering backends, state management and state locking we'll be seeing. Then we'll be covering Terraform imports, Terraform pull, Terraform push, modules and workspaces we'll be covering. Then we'll be covering resource meta arguments like count for each depends on. Then lifecycle rules like ignore changes, create before destroy, prevent destroy, which are part of lifecycle rules. We'll be covering them. We'll be covering dynamic block, then provisioners, local execute, remote execute. As part of these provisioners, we'll be covering. So these are the 11 topics which I have listed to cover as part of this series. And it will be a 10 days um, series, and I will begin at 8 a.m. sharp, and I try to close by 9 a.m. Few times I might extend like 10 or 15 minutes. Few times it will be a shorter sessions. Basically, it will be a 1 hour sessions, and we'll be using Azure Cloud for labs. So this is the plan for this series, and these will be the topics. Any questions or anything before we go ahead from anyone? Okay, I'll go back to the slides. So what is Terraform? We have been hearing Terraform, right? So what is it? So it is one of the famous tool, I would say, as part of infrastructure as a code. We have other tools also in the market, but still Terraform has been a bigger player. Okay, it is one of the tool among infrastructure as a code, and we use this tool to define cloud and on-premise resources for the deployments of infrastructure. We use this, and as part of this Terraform, we will write the code that is human readable, reusable, and version controlled configuration files we'll be creating. So it enables a consistent workflow to provision and manage infrastructure lifecycle, and manages low-level compute, storage, network, and high-level DNS SaaS components. So basically, Terraform is an infrastructure as a code tool, and we use this to manage our infrastructure for the deployments or keeping a desired state. Like I want this state to be deployed for this environment. These tools or these resources I want to deploy. So for that desired state, we use this Terraform. We'll be seeing this in depth in the coming classes. During the labs, you will be clearly understanding how we are using, how we are creating the resources in the cloud. We have the clear labs. You will be understanding more about what it is. Next, coming to the history of Terraform. So back in 2014, the first release happened, that is Terraform 0.1, and it contains core CLI workflows like Terraform init, plan, apply, destroy. These related uh, application packages were released, and the first release was in 2014. Then in 2016, the official Azure support begins, and Azure RM providers were released. In 2021, 1.0, which was a stable version, it was released in 2021. It contains lifecycle rules, import, state refactoring. Close to 700 resources can be created from the Azure provider. That was released in 2021. In 2024, BUSL licensing and Open 2.4 fork. So what is this? Till 2024, what has happened? So it was an open source. Everyone was able to use it and download and use it. It was open source. But in 2024, Terraform, the HashiCorp, the company, right, who actually developed this Terraform, they decided to make it a licensed version. and they want to charge it. So it happened in 2024. They called it BUSL, Business Source License. And from then, Terraform is no longer fully open source. So to overcome this, OpenTofu was released. It is an open source community. So it forks the Terraform developed APK. Okay. So this was done by the OpenTofu and with the help of other major providers like it was supported by the other communities as well. So this is some history about Terraform. So this is one of the important slide I would say, because even if you go to some interviews, people will ask, why are you using Terraform? There are other cloud, other tools in the market. Why do you want to use Terraform? What are the benefits? I'm using Az I'm using Azure Cloud. Instead of going for ARM templates, why you want me to go for Terraform? All these questions they will ask. So this slide explains why we are going for Terraform, and this actually gives the answer for that. So Terraform, ARM templates, AWS CloudFormation. What is the difference? So the feature like cloud support, it supports multi-cloud. It supports AWS, Azure, GCP, Kubernetes, VMware. If you want to create any resources in any of these technologies or the clouds, it is possible with Terraform. Whereas when it comes to the ARM templates, the Azure proprietary tool, you can only create resources in the Azure, not on AWS or GCP. Likewise, AWS CloudFormation, it supports only AWS. So that is a major difference, I would say. And the languages, when it comes, right, Terraform uses HCL, ARM templates JSON, and AWS YAML and JSON. State management, in Terraform, we manage state, but it's in ARM templates and AWS, it is there, but not fully. Okay. Same like in a Terraform, it is not fully there. It implicitly manages and everything. Modularity, so strong modules were developed for Terraform. Here in ARM templates, we have nested templates like that. And in AWS CloudFormation, we have stacks and nested stacks. So Terraform is sitting on top of all these multi-cloud, it has more flexibility and has a richer language. ARM templates and CloudFormation are cloud native, but restricted to single cloud provider. So that's the reason we are going for Terraform. I'll go to the next slide. So how this Terraform is working? So how it is working when I make it is so we are able to work with AWS, we are able to work with Azure Cloud, we are able to work with GCP, able to work with VMware or Kubernetes. How it is actually working? Any cloud provider or any application, right? It will have APIs, application interfaces. If you are able to call those application interfaces, you will be able to do your work. Like you want to switch on a fan, right? What do? We go to the switchboard and turn it on, right? So this is the interface to turn on the fan. Similarly, I want to create a VM in Azure Cloud. So you go to the portal of Azure, then you go to the um, create VM console, then you go through the wizard, and at the end you click on create. What is happening in the wizard? You are trying to give some inputs. It is collecting some inputs from you. At the end, when you click on create, it is hitting this API. It is hitting this API with the inputs you have given. So similarly, Terraform, what it is doing, it has developed the providers. What it does, these providers, they know how to call these APIs. It can be any cloud, Azure or AWS or GCP. These providers know how to call these APIs. So we use these providers to call these target APIs. So this is how the Terraform is working with, and it is able to make calls or work around with different providers like Azure, AWS, or GCP and others. So as part of this slide, I have kept 3 points. Terraform manages resources through platform APIs. Here, platform means the cloud providers. Providers allow Terraform to interact with cloud and service APIs, and it enables support for virtually any platform with an accessible API. So this is how we can install Terraform. Uh, you can install it in Linux box, you can install in Windows, you can install in Mac OS. Let me quickly open this. So so in this slide, there is a link. I clicked on that. Once you click on that, you'll go to this page. You see in this page, it is a Mac OS. It has two commands, brew commands to install Terraform. This is for Mac, and this is for Windows. You can download and install Terraform binaries. And Linux, you can go ahead and run these commands. Now that I'm using Mac OS, let me show you this in, in my laptop. So I just run first command. So it will go ahead and download this, then this will install. So I have already installed this Terraform before, so it has not actually gone through the entire process. It just says brew reinstalled Terraform. So if you are using Windows, you can download and install. It is a simple process. You just need to go through that wizard and just install. And these are the commands if you are using Ubuntu or anything, Linux versions. You can run these commands, then install Terraform. How do you check once you install Terraform? Just use Terraform. It gives this kind of output. You can check Terraform version, hyphen version. It gives the version. So this is how you validate whether the Terraform is installed or not. Going back to the slides. So this slide covers Terraform providers. Terraform providers are plugins that let Terraform interact with service APIs. As we seen before, related to APIs. So these providers are plugins that will call APIs. Work as a driver or bridge to manage resources on cloud providers like Azure, AWS, GCP, which are given here. And thousands of providers are supported by HashiCorp and community and available in the Terraform registry. All these providers are available in the Terraform registry. Several type of Terraform providers are available now. So official providers, which are maintained by HashiCorp, are like these developed and maintained directly by HashiCorp. Like for example, AWS, Azure RM, GCP, Kubernetes Helm are maintained by HashiCorp. And partner providers, what are partner providers? These providers are developed and maintained by third-party organization that partner with HashiCorp. What are partner providers? Here, Alibaba Cloud, Oracle Cloud Infrastructure, various SaaS platforms, and enterprise tools. Next is community providers. What are these community providers? These providers are developed and maintained by individuals or organizations within the Terraform community. So community providers are maintained by individuals or organizations within the Terraform community. Examples given are GitHub, Splunk, Datadog, and many other platforms. The last one, custom providers. Users can also develop their own custom providers for specific internal systems or unique infrastructure needs, not which are already not covered by the existing providers. These are typically written in Go and leverage the Terraform plugin SDK. So here is the link. So once you open this link, click on this link, right? You can see all the different providers. On the left side, you have the filter, their official partner community. You just want to see official, you get to see them. So I'll uncheck this. These are official providers: AWS, Azure, GCP, Kubernetes, and few others. If you just want to see the partners, so these are the partner providers. And these are community providers. So this is the link where you can check the different providers. Any questions so far? So far, so good. Okay, I know first day is more of theory. I should have told you in the beginning. So the first day will be more of theory, but from second day we'll be having 70% of labs. Mostly labs will be there in Terraform. We'll be doing all the labs for all the topics we have. But first day, like any other course, we have some concept which we need to cover and understand some basics. That's why we'll have a lot of slides on the first day. You can ask any questions in between also. So far what we have covered what is Terraform. We have seen what is the history of Terraform. We have seen what is the difference between Terraform, ARM templates, AWS Cloud Formation. Then we have seen how Terraform works. Then we have installed Terraform. Then we have seen Terraform providers and what are the different type of providers.
Ramesh, sorry to interrupt here. Can we get that link to install the Terraform?
Yeah, I'll share these slides. I'll
Okay, great.
I will either put it in OneDrive and share the link. That is
Yeah,
one
so,
option.
yeah,
I did like this in Azure session, but this time I'm thinking to put it in Git repo. Uh,
yeah, great. Thank you.
yeah, any one of them I'll try to share the link. And you can access all these slides. These slides has the links. Okay, now let's see Terraform block, provider block. So the first one, which is in blue, right? We have declared Azure here. So it is calling Azure provider. Basically, this provider we use when you are trying to call the resources of Azure. And the one on the right side, this one is of AWS. Okay. And yeah, you see here, we declare this provider like this. There is a Terraform, then inside this required providers, then Azure RM. Then I say this is the source from where you need to download and the version number we declared here. Similarly for Azure, similarly for AWS, we declare AWS here, the version number here, and just changes the source instead of Azure RM, it is AWS. And this is just name AWS Azure RM. So this is how we declare. And I have this link here. So there it has more details. And let me try to open this. This is Azure provider. You see these versions. It says providers, Hashika, Azure RM, then version 4.54.0. There are other providers also. This is released just 11 days ago. This one is like 16 days back. So we have different providers. When you click on all providers, it still goes down, and we have many, like 7 months, 8 months, 9 months, a year ago, 2 years ago. So many are there. We'll continue, and going back to the slide. So this is how we declare Azure provider. Terraform basics. So what goes inside the root directory? So when we are creating this infrastructure as a code, right? What happens? We need to start developing this code. So how this project looks like? So generally it will be like your main folder, my Terraform project. Uh, it can be, you can give any name, a easy naming convention you can use so that you can identify, okay, this project is related to this. Then inside that folder, you'll have main.tf. TF is the extension of Terraform file where you declare all the resources. Main.tf, variables.tf, outputs.tf, providers.tf. Then we have terraform.tf vars. We'll see what is tf vars, why we have these different files. So generally, can we keep everything in one tf file? The answer is yes. I've been using 4 files here. I created 4 Terraform files here. I say this is my project. But can I keep everything in a single file? Yes, we can do that. So if you open a Terraform file, this is a Terraform file. This is a provider. Uh, till here, Terraform, till here, provider. Then here is resource. This is output. So what I'm doing here, I'm putting my output here. Uh, outputs block here, providers block here, variable blocks here, and main block, the resources, modules, calling modules, all these in here. But instead of that, I can keep everything in a single file. That even works. If we can write everything in one file, why do we use multiple files? So if we can write everything in one file, why do we use multiple files? That is the question we have. Because Terraform projects become larger. So in a larger enterprises, if you keep everything in a single file, like main.tf file, I want to keep everything, provider block, resource block, or modules, everything. It becomes larger. So that's the reason. Having everything in one file becomes unreadable and unmaintainable. That's why we maintain different file. Each file represents one responsibility. Provider.tf, it contains provider block. Variable.tf contains input variables. Main.tf contains resources. Output.tf contains outputs. Locals.tf contains computed values. Important note is that multiple files are for humans only, not for Terraform. So these are for our easy understanding. For Terraform, it is not like that. Terraform loads all .tf files in the folder in any order. It will pick in any order it will pick and merges them into a single configuration file. So when you run this Terraform file or Terraform code, what happens in the backend? It picks all the .tf files from the root directory, the the folder which we created for our project. It picks all the TF files, then it will merge everything into a single configuration file in the backend. So these files are for us only, not for Terraform. That is one point you should note. So there is one question generally which I came across. People will ask, I have variables.tf file and main.tf file. So these variables will be loaded to the main.tf file only or to all the other different TF files? That is the question. The answer is it loads for all. These can be passed for all, and variables can be declared in any of these TF files. Because when you understand in the backend, in whatever the way you are passing, at the end, Terraform is loading all the TF files and it is merging it as a single configuration file. So don't get confused with the different files. We will be covering each one of them. What is a provider.tf file, variable.tf file, main output.tf file. We have we have classes for each one of them. Today we just covered providers. What are providers? Eh, Do anyone has any questions before I go further? Are we good? Yes, Ramesh, we are good. Yeah. So next is Terraform CLI workflow. So as part of the CLI workflow, we have four different things. First is Terraform Init, Terraform Plan, Terraform Apply, Terraform Destroy. For today, we will be covering Terraform Init, and tomorrow we'll be covering the other three. So what is Terraform Init? Terraform Init is the first command you run in any Terraform project. So this is the first command. We run it in Terraform project. It prepares your working directory so Terraform can run other commands like plan and apply. Think of it like setting up all tools and dependencies before building a project. So it prepares plugin directory, keeps providers under .terraform folder, downloads providers, example like Azure RM, AWS, Kubernetes, GitHub, all these things it will download, configures backend if there are any, install the required modules. Terraform directory should not be committed to repository. So this is one point. We should not be committing .terraform file to the repo, and creates .terraform log HCL. So this is one more file which gets created. So dependency log file listing what it is. It is a dependency log file listing exact provider versions and hashes. So it is a log file. It has the provider versions and hashes. And this file we should not be committing. We should be committing this to repo because teams and pipelines needs the exact same provider version. That's the reason we need to commit this to the repo. We will see exactly what it is. So we have one lab, providers declaration and resource declaration. As part of this lab, I will be showing how do we declare providers, resources. We'll run Terraform init, check the output, check providers download, module declaration will be doing, then run Terraform init and validate remote modules getting downloaded. So we'll be seeing them in the lab. I just have one file here, inside this one. So this is a Terraform block, provider block, step one. So from this URL, I have picked this block. So you can see the version I'm using here. Okay, 4.54.0. So I think this is the latest one which I picked. Then here, provider, Azure RM block. You see here some of the things I have mentioned, like subscription ID, client secret, tenant ID. So these two, right? These two are related to the provider block. So sources are from here. Quickly open this. So this is Azure RM provider. I'm using 4.54. And next is this one. So this part I have picked. Okay, so it says Terraform required provider is this, and this is the version. I just changed the version. And provider is Azure RM, and subscription ID, client secret, tenant ID. These are used to connect to my Azure account. So let me show you how we can update these values. I went here. I'll open portal.azure.com. So here I am. This is Azure portal. Okay, this is my subscription. And I need these details now. Subscription ID, client secret, tenant ID. So this is a stable block where we don't have to change anything. Only the version number we just update. But this block, something important where if I'm trying to create resources, work with Azure cloud, this is one block which does authentication with Azure cloud. And we need to provide these details. I'll go to Azure Entra ID and so here you can see tenant ID D66, right? It's starting with D66. And here I have updated that value, tenant ID. Then this one is done. Then I need the subscription ID. I get it somewhere here. Okay, before that, I'll show you this one. I created this secret new registration. You can say Terraform SP service principal. You can a create this and keep everything as it is. Just click on register. You create a new SP, then you can say new secret. I will say this is Q4 and I need it for 30 days. Click add. So I'm creating a new secret. So we need this secret which can be used to connect to Azure. So this is the value. We see this uh, only once, the first time. Once you go back to other page, you won't be able to see this again. So this value, something like this, the client secret I have updated. Client ID, I want to know. Client ID you can pick from here. This is the client ID. Now that I'm using the other one, this is the one. Here the client ID, 9784. Here is the client ID. Client secret we have already seen. You get from there. You go to secrets, then you create the secret. It is starting with EU. You can see it is EU. You can create from there. The leftover is subscription ID, which you can get it from, I think it should be here, or I can go back directly to the subscription and pick. So this is my subscription. I can take it from here. So this is the subscription ID, 19. It is starting with 19. So this thing. So these details are updated. Now I think I'm good to authenticate with my Azure service provider using these details. So this is a non-interactive, it helps for a non-interactive mode of communication with my Azure service provider, where I can create resources, I can get the details of the resources, all kinds of communications can be done only when you authenticate. So this part will help with that. So this is one block. So with this, the provider block is completed. Then I have a resource block here. So I'll be covering in detail about the resource block tomorrow. So right now I have just declared, okay, I just want to create a resource group and which is in Central US. I want to create a VNet here and some details related to VNet subnet. We'll be covering in detail tomorrow on this. I'm not going through um, each line now. So module block, I have commented out just to show you that how the modules are getting downloaded. You see now this is the root folder and you see only one file. But when I run Terraform Init, what it does, it will download the provider. Which provider? The provider which we declared here. So I have typed Terraform Init here. So now I'm initiating this. So now it is installing this Terraform provider. You see new folders are formed here. .terraform is one folder, and this is a log file. So this log file has hashes and versions of this provider. So this file we can commit to the repo, but we should not be committing the providers like you see here. So inside this .terraform, I have a provider, then registry.terraform, everything till here. So this is something which got downloaded now. So the provider is downloaded. You see the command is completed now. Step one is done. Uh, Now I will uncomment module block and run Terraform init. RG module sourced from the Terraform registry. Terraform will automatically download this module during Terraform init. You can also use modules stored in GitHub or any other accessible location. Modules which are stored in GitHub or any other accessible location you can use. Right now, here these lines, let me uncomment. Here the source I have given, right? This is from the HashiCorp. So location. So it will download the AZ module resource group, Azure module it will download. You can also use modules stored in GitHub or other accessible location. Once you run Terraform init, you can see modules downloaded under modules. Let me run this Terraform init, then we'll see what is happening. Terraform init. So this is now done. Okay, let me save it first. File save. It did not recognize that these lines are uncommented because I did not save it. Now if I run Terraform init, you see initializing modules and downloading registry.terraform.io. And this is the path which I mentioned here. It is downloading from registry.terraform.io. And where it downloaded? Inside .terraform. The modules are downloaded here, like the RG and RG label modules are downloaded here, and providers are here. These are downloaded because we mentioned this block here, and providers are downloaded because we mentioned it here. So these are downloaded now. We just initialize it so far. We did not run anything. We did not create any resources or anything. But this is the first command. Terraform initialize is the first command we run just to initiate this code which we are developing, or the root folder where we are developing our code. Any questions? So this is what is planned for today. So we have done this lab, and this was the last topic for the day. And yeah, we'll be covering the other topics tomorrow, like have day 2 from tomorrow. We'll be covering Terraform plan, apply, destroy tomorrow. And we'll be having a lab related to that. Any questions so far before we close the call?
No,
So we
Ramesh.
always go with the latest version of the Terraform while working on the real-time project, or it depends upon the client requirement. So,
Yeah, good
like,
question.
if we already have a project which is being run using Terraform from legacy versions,
Yeah.
and we want to go with the new version,
Hmm.
and we need to see the compatibility, right? Whether the
Correct.
new version has all the modules or the plugins which we have
Yes.
used earlier. So how can we like go with that?
So you have the legacy system where you are already using some Terraform version, like suppose 2.46 is what you are using. Okay, and you have been using that. What is happening? So when you are running this Terraform init, this hash is developing, right? Based on that Terraform provider version, it is developing that hash, and you are committing that. So all the users are using that hashes because that hash is related to your provider version. Now, what is happening? Some of the modules or some of the resources when you are creating, it is not working. Like, for example, let's take in Azure, you have Event Hub, right? Event Hub is one of the resource. It may not support 2.46. You need the latest version. So you checked in the net, okay, which version will support to create Event Hub? It mentioned 3.2.0, 3.2.0. Now you have to bring that, create this Event Hub and you need to update this version to 3.2.0. So what you will do, you have to run it locally and test it. Okay, if I go ahead and use this version, will it break uh, other resources? So that you have to check the compatibility. Is this version, latest version, compatible with other resources? In most of the cases, it will be compatible.
Okay.
Most of the cases, it will be compatible because what is happening when they are releasing the newer version? Few times they develop few of the features. For example, I will take a VM and you are passing this queue till 2.446 and now it is allowing you to pass another new argument like for example like vnet subnet is one of the
Mhm.
argument you want. It allows you to pass in the latest version, but when they are creating the new version it will be an optional argument. Even if you have not declared in the existing one, it will go further and deploy.
Okay.
But still, the compatibility is one big thing you need to check. And
Okay.
during Terraform plan, right, you will understand, okay, whether it is compatible or not, what is the issue and all. And you should start going and fixing that.
Okay.
Did I answer your question?
Yes, I got it. So most of the cases, 90% of the time, the latest version comes with the legacy features too. On top of that, you're gonna get the new features. So
Yeah,
going with the new version, it's better, always better to check with the compatibility and go with the new version. Yeah.
yeah.
Got it.
Any other questions? Okay, we will wind up for the day. I will give you back 10 minutes of your time. We can catch up tomorrow at 8 a.m. Thank you all.
Thank you, Alan.
Thank you very much. Have a good day.
Thank you.
Thank you,
You too.
Ramesh. Have a good day.
You
Yeah,
too.
thank
Bye. Thank you.